We're now going to look at solving exponential and logarithmic equations where you may have to use a calculator in order to solve them. So what I want to first talk about is the common logarithm. And what the common logarithm is when we have a log base 10. And we call that the common log because that's the one that is sort of installed on most calculators and what mathematicians go back to if they're having troubles with other bases. So let's talk about that real quickly. If you see a logarithm that does not have a base, and I mentioned that briefly before, we assume it's a base 10. So notice log base 10 of x is the same thing as just log of x. Okay, remember when we have square roots, there's really a 2 there, but we never write it. When I say x, there's really a 1 there, but we never write it. So there's certain times in math where we don't write any numbers, but we assume the number. So if we don't see a base for a log, we know that it's the base 10. Okay? However, what happens when we don't have the base 10 and you have a calculator? Well, then we learn something called the change of base formula. Okay? And what the change of base formula is, and this is going to be super important for you to have memorized, is that log base b of n is the same as log of n over log of b. Notice the bases are really tens. Okay? So let's look at an example together. If I ask you to find the log of 7, in your calculator, you literally can just type that because we know that that base is 10, and that's the one that's installed into your calculator. And so when you do that, we literally just hit the log function, which there's a log button right on your calculator, and so we would just do log of 7. And that gives me approximately, it says round to the nearest 10,000, so 0.08451. Okay, so please just remember this is the exact same thing as log base 10 of 7. So that one is nice and easy since it's already a base of 10. However, let's do number 2. Number 2 says log base 4 of 8. That does not have the base 10. So in your calculator, you're going to use the change of base formula, which is log base 10, or log of nothing, of 8, all over log base 10 of 4. So the change of base formula is the log base 10 of the larger number, which is 8, over the log base 10 of that little base. So now we put that into our calculator. What's important to remember is to watch for any parentheses and so forth. So in the calculator, it'll be log of 8, close the parentheses, divided by log of 4, close the parentheses. And when you do that, that is exact. We get 1.5. Okay, you try number 3. Write the change of base formula and then pop that into your calculator to come up with an approximation. Know this, we can actually solve logarithms where we can't necessarily just do it in our head. So for example, and exponentials. So for example, on number 1, this is an exponential. So we need to use logs because I can't write 8 as a base of 3, right? If this was a 9, I could write this as 3 to the x equals 3 squared, but I can't write 8 as a base of 3. So we're going to use logs, and I'm going to change that to log form. So convert to logarithms would mean we have log base, and I'm going to keep the variable where it is. So x equals the log base 3 of 8. So now I put that right on into my calculator. Remember, we'll use that change of base formula. So this is really saying the log of 8 over the log of 3, where those little bases are 10. So we'll pop that in, log of 8, close the parentheses, divided by log of 3, and we'll continue with rounding to the nearest 10,000th, so 4 decimal places, 1.8928. Please make sure we know our rounding rules, okay? And I should make this be an approximation symbol. Okay, now, sometimes you're not going to need to use a calculator, right? If I look at number 2, you can drop the calculator completely because we can just make these be the same bases. right? 16 is the same thing as 2 to the 4th. So no calculator necessary here. I just drop those bases and set the exponents equal to each other. So 3x equals 9 and x equals 3. Okay? Now notice I haven't been checking any of my work, and that's because these are exponentials. It's fine to have x be positive, negative fractions. It doesn't matter for my exponentials. Okay? So we're going to do one more of these together, and then I'll have you try some of them. But again, you're taking a look at, do I need to convert to logarithms, or can I just rewrite? Okay, so I'm going to have us do number 5 together. So number 5, I can't write these in terms of the same base, right? 3 and 5, I can't do. So what I'm going to do is the fact that we have 2 exponentials here is that I'm going to take the log base 10 of both sides. So by doing that, we get the following, and this allows me to get that common logarithm written right away. So here we are. Well, I still have these exponents. Don't forget this property that when you have exponents, we can put them out front once we have a logarithm. So this is really saying x plus 2 times the log base 10 of 3 equals x minus 1 times the log base 10 of 5. Okay? So from here, what I'm going to do is now distribute. This is saying x log base 10 of 3, and you don't need to write base 10 each time. I'm just doing it for our notes here, plus 2 log base 10 of 3 equals, distribute on the right side, x log base 10 of 5 minus 1 log base 10 of 5. Now that I'm at this point, I can now get the x's to one side and the constants to the other. Notice I haven't plugged anything into my calculator yet, because if I do, I'll start to be rounding too early on. So I'm going to take this guy and move it over, and I'm going to take this one and move it over. Okay, so again, getting our x's to the left and the constants to the right. So when I do that, I'll have x log base 10 of 3 still, and now I'm going to subtract x log base 10 5. So my x's are to the left. On the right-hand side, I'll still have the negative log base 10 5, but I'm going to subtract now the 2 log base 10 3. Okay? Now, I still have 2 x's showing up. So I know here, since they both have an x, I can factor that x out. So now I have log base 10 of 3 minus log base 10 of 5 equals, on the right-hand side, still no calculations in that calculator because we don't want to round. So I leave it as is. Last but not least, I'm actually going to divide through to get x alone. So I'm going to divide both sides by that quantity of log base 10 3 minus log base 10 5. And I do that to the right. What I'm left with now is an exact answer. Okay, so even if you don't have a calculator right now at home, you can do all of this part out and give me the exact answer. We get x on that left-hand side, and on my right-hand side, we have negative log 10 5 minus 2 log base 10 3 all over log base 10 3 minus log base 10 5. That's my exact answer. Well, what is that as an approximation? So here's where you need to be very careful with your calculator and grouping symbols. We want to make sure our entire numerator is separated from my denominator. So you need to make sure that in your calculator, and I'll show in orange for the calculator, we start with a parenthesis. When we hit the word, negative log, the base 10 isn't there, a parenthesis opens up. So you'll need to make sure to close the parenthesis on the 5. Then we'll hit minus 2 log 10, and it'll open up. And then you'll have to close that 3. However, please make sure to hit a double parenthesis because we need to close the numerator. So our 5s are in parentheses, the 3 is in parentheses, but we have a parenthesis to begin and to end to separate the numerator. Now we can hit division, and then same deal. Parenthesis to separate the denominator. Once you hit the log button, a parenthesis will open for the 3, close it. Minus log 10, 5, parenthesis will open, close it, and then close the parenthesis for my denominator. Okay, so go ahead and plug that in, and let's see if we come up with the same answer. Remember, you're not typing in any tens, right? That's what's assumed right on in your calculator because it's the common logarithm. And I always, before I hit enter, I always double check that I have typed things in correctly so that I don't have to go back to retype. Okay, so again, I have a parenthesis, negative log 10, 5, minus 2 log 3, close the parenthesis, divide, open log of 3, minus log 5, close, close. All right, and I get approximately 7.45198, so that would become 20. And there's my approximation. Okay. So that is the longest type of calculator problem that you'll have. And notice this was more challenging than the one we did on number 1 because we have exponential expressions on both sides. So we need to get those variables to the same side and then eventually isolate it. You try 3 and 4. Pay attention. Do you need a calculator or not on them? And then make sure to go nice and slow if you do have a calculator question. All right, let's just review our logarithmic equations. So those were exponentials where we used logs to solve. In this case here, now we have on number 6, we have a logarithm. So remember, to undo logarithms, we use exponentials. So we double check. Is there log on both sides? Nope. So I'm going to need to convert to exponential form. And we're already condensed, so we're good to go. This means we'll have 5x plus 7 equals 3 squared. So 5x plus 7 equals 9. Subtract 7 gives me 2. X equals 2/9. Oops, sorry, 2/5. So just double check always. Now that this is a logarithm, we must check our work. Okay, so in this case, if I plug in 2/5, we are fine because we'll get a positive value in that logarithm. So we're good. Okay, you try number 7. That's a review one. All right, and the last piece is same solving exponentials where we may have to use a calculator, but they're inequalities. Now remember, for our inequalities, we want to check our solutions, but it's okay if we have negatives and positives and fractions and so forth. Okay, so I will do one of these with you and you do the other. I'm going to do number 9. So if we look at number 9, these bases cannot be written with each other. So I'm going to follow this problem just like I did on number 5. I'm going to take the log base 10 of both sides. Now I'm going to drop that 10 so that you understand you don't always have to write it. Once I'm here, I can take those exponents and write them out front. So this is really saying y times the log base 10 of 4, but I don't need to write the 10, and then 2y plus 1 times the log base 10 of 5. We will distribute, so y log 4 is less than 2y log 5 plus 1 log 5. I'm going to get my variables on one side, so I'm going to subtract the 2y grouping. At this point, I will factor out the y right here. So I take out a y, I'm left with log 4 minus 2 log 5, and it's less than log 5. From here, we're going to divide by that quantity. Now, one important thing that you do check in this case, okay, is that because this is an inequality, we need to actually know, is this log base 4 minus 2 log 5, what I'm dividing by, positive or negative, right? Because if it's negative, I need to flip my symbol. So you can do this in a couple of ways. What I do is I actually type in that denominator. So we'll have log of 4 minus 2 log 5, and I just hit enter. That gives me negative 0.7958, so forth. So since it's negative, I know I'm dividing by a negative, so I need to flip my inequality symbol. But instead of rounding too shortly, I'm going to keep that long answer stored into my calculator. I'm not going to clear anything. I have that negative 0.79588 in my calculator. And now what I'm going to do is I'm going to hit log of 5, because that was my numerator, and now divided by, on my calculator, the last answer you have is stored in, so you can hit the second button, and then where the negative sign is, it says ANS, answer. And so in my calculator, it's going to look like the following. Log of 5 over ANS. And what that's doing is it's dividing log of 5 by that value that we just found. So you don't have to retype it. And now I can hit enter, and I get is greater than about negative 0.8782. Okay, so you try 8 and 10. Remember, our goal here is if we can write them with the same base, fantastic. Otherwise, we're going to convert to logarithms using that common log base 10.